Today we're going to talk a little bit about the difference between a relation and a function. So let's start with a relation. A relation is just two groups of items that are correspondingly grouped up or paired up. Typically we call these domain and range. So I have a domain here listed with boys' names and a range here listed with girls' names. And if I have a relation, these things are paired up some way. So I'm going to indicate that with an arrow. As long as they are paired up, it's fine. Now, the neat thing about relations is they can be paired any way they want. So we could have some repeats within our parent. And it doesn't matter. They are just paired up. Now, in math, we tend to see these as ordered pairs. Sometimes we see them as graphs. Sometimes we see them as these mappings. So that's a relation, as long as things are paired up. When we get to function, it has a few more rules. A function is still a relationship, still a relation. Okay, so things are still paired up. But now there's a special rule. And the special rule is each element of the domain is paired with exactly one element of the range. So we have more rules when we're talking about a function. So I'm going to take my arrows out, and now I'm going to pair them a little differently. So now I have to make sure when I'm looking at my domain that everybody in the domain is only paired with one member in the range. So when I add those extra arrows, maybe Alex pairs up with two people, all of a sudden it's not a function. This is still a relation, but is definitely not a function anymore. Okay, so I'm going to take that arrow back out. Now, you have to be careful because it doesn't say anything about each member of the range paired with one member of the domain. So we have to be careful about that. So, if I do something like this, and I'm going to pick on Wanda today. If I do this, if you think about it, every member of my domain is only going to one member, exactly one element of the range. Doesn't matter that these in my range aren't being used, everything's going to just one thing. As soon as I put that second arrow off of somebody, it's not a function anymore. Then it becomes just a relation. This is still a relation, but it's a special kind called a function. Now, it does not work the other way. If I pick on Bob today, if I do something like this, I'm already not a function because Bob is being paired with more than one member or one element in the range. So anything that's paired up is a relation. So yes, this is a relation, but it doesn't follow our function rule where every element of the domain is paired with exactly one element of the range. Now, in math, obviously, we use numbers, and we have different ways of doing this. Sometimes we'll map these out by graphing. So notice I have my domain here and my range here. And the way we find out if something is a function is we use the vertical line test. So here's my vertical line, and I'm trying to find a spot where this vertical line touches more than one point. And if I can't do that, this passes the vertical line test. This is now a function. If at some point I have this vertical line and it goes through 2 points, it hits more than 1 point, it fails the vertical line test, and this is not a function because this number here, whatever it is paired with two numbers in the range. So we can do this with mappings. We can do this with the vertical line test. We're used to seeing this T-chart, this XY table, whatever you normally call it, where my domain is my X and my range is my Y. So I'm looking in my domain to see if there's any repeats. It doesn't matter that there's repeats over here, because if we go back to our definition, each element of the domain is paired with one element of the range. So 1 matches with 2, 3 matches with 3, 4 matches with 2, 5 matches with 6, and 6 matches with 4. As soon as we would have a repeat over here, Now we have a relation, but no longer a function. When we talk functions, we like to use function notation. And it seems like it's really complicated, but it's a simple change. Instead of writing things as y equals and then having our function, we change the y equals to f of x equals. So if I had an xy chart here, and I don't see a y, I instead see an f of x, I still have an xy chart. It's just in function notation instead of xy notation. The nice thing about function notation is I can take my function and I can plug things for x repeatedly. So in this case, I'm supposed to take whatever x is and add 3. So this first example says plug in a 1. So I plug in a 1 for x, and I evaluate that function to be 4. This next one says replace x with a negative 2. So everywhere there is an x, I replace it with a negative 2, and I evaluate that, and I get 1. And the nice thing about function notation, I can plug anything in there. I can plug numbers, I can plug decimals, fractions, I can plug other variables. I can even plug other functions in. So this one says I want you to replace x with a t. So everywhere I see x, I replace with a t. So that's the basics on functions versus relation and function notation and different ways of determining if something is a function.